discussed about the 5 trend based method. In that, last one was simple graphical method. As a part of graphical method, there is another method that is called comparative graphical method. It is somewhat similar to simple graphical method. What we do here is, first of all, we will take a city under consideration whose population has to be estimated. Let it be city X. Its population records were analyzed, and the present known population was 50,000 right then. So then there is a necessity to estimate the population over the successive years. What we do here is, first we will plot a graph as similar to the simple graphical method, population versus time in years. So this is for the city X population. It has reached 50,000 at 1970 itself. The very next step is, if it was simple graphical method, we would have just extended this graph and we would have identified the design population for some design period. But here we will consider, as the word itself, method itself signifies that we will consider the comparison, means we will consider other cities which are similar in conditions, circumstances and population growths. Those similar cities are identified and selected. Let it be city A, B, C, D. Around 5 to 6 cities were selected. Then what we do is, say for example, for instance, we will take, let us take city A into consideration. We will analyze the population records of city A. We will analyze the population records of city A. After analyzing, we found that city A has reached 50,000 population at 1900 itself. Now, we should take the population records beyond 1900, that's it. So first we will analyze the population of city A, and it is found that city A has reached 50,000 population at 1900. 1900 itself it has reached the population 50,000. So beyond this 1900 population records are taken and plotted over here. However, it has to be plotted here like it should be start from this. That means let it be P. P is the point at which the city X under consideration has reached the population 50,000. From here, this population record has to be plotted like this. Let it be. So this is the city A's population record graph, considering records beyond 1900, from which it has reached 50,000. So likewise, other cities' population records are also analyzed, and that will be plotted over here. So this might be for B. This might be for this. So city C may go here. So city D is going here. So next, what we do is, we will, as similar to the simple graphical method, we will just extend this city X graph, considering the influences of the population growth of different cities which we have considered. So after extending, what we do, same as that of simple graphical method, for some design period, for any design period, we can identify the design population. So this is how we will estimate the population, by comparing the cities which are similar in conditions, circumstances and population growth, and we will extend the graph of the city X under consideration, making influenced with the population growths of different cities, and we will find the design population. Next method is master plan method or zoning method. Big cities and metropolitan cities are not allowed to develop in haphazard ways or natural ways. They are developed in planned ways. That means local authorities and government agencies will prepare a master plan for a city, and they will zone the cities as residential zone, commercial zone and industrial zones. So then they will restrict the advancement or development or extension of these cities in the zones, and also they will fix the population density for particular zones. For instance, let us take a residential zone into account. Let it be allowed for 5 persons per plot, and also let it be allowed 1,000 plots per residential zone. So then, if you want to find out the population, if you want to know the design population when it is fully developed, the design population will be 5 into 1000. That's it. 5000. So this will be the population when it is fully developed. The city is fully developed. So this is how we will predict or we will estimate the population using zoning method. This is very suitable method when it is cities are well zoned, and we can supply, when water supply systems are considered, it is very useful so that we can supply the water as per the requirements. In this method, that is the ratio method, the population of the local city or the city under consideration whose population has to be estimated is expressed as the percentage of the nation's population. In order to do so, we will collect the population records of the local city and the population of the nation for about 4 to 5 decades. Then the ratios of the population of the local cities to the population of the nations are worked out, and the graph is plotted between time versus the ratios which we obtained. So the ratio will be population of city under consideration whose population has to be estimated, and the population of nation. So the graph is plotted. So this might be the graph. Then in order to estimate the population, we will just extend this graph so as to extrapolate the ratio for the design period. Suppose this is the design period, we will extrapolate the ratio like this. After extrapolating the ratio, we will suppose it might be A by B, some number it might be. So A by B ratio, for this ratio we will multiply the population, nation's for this ratio we will multiply the nation's population at this time. So then we can find out the population of the city at that time. So this is how the population is estimated in the ratios method. This method is very much suitable when the city's population or the local city which is under considerations, population growth is in parallel with the nation's population growth. In this method, that is growth composition analysis method, here the three major factors affecting populations are considered. Those are birth, death and migration. So in this method, population is estimated like this, where Pn is the population at any desired year, is calculated as a sum of present population added with natural increase. Natural increase will be birth as well as death plus or minus migrations. So natural increase further can be calculated by using this formula, where T is the design period and P is the present population, IB is the average birth rate per year, ID is the average death rate per year. So in order to get reliable results from this, reliable estimate from this method, we need to get actual birth rate and actual death rate and migration rates of that country or of that city by the local authority. So if I get actual birth rate and actual death rate and migration rates, I can depend on the estimates obtained this method. So this is the last method, that is logistic curve method. In earlier classes I explained you regarding the normal consideration or normal circumstance of a city. In normal circumstances of the city, the city's population growth will follow the logistic curve. So P.F. Wilst represented this logistic curve by an autocatalytic first order equation. If that equation is simplified, this is the required equation of the logistic curve. Here it is represented, where P at any time it is represented in terms of population, so saturation population, that is PS, and M and N, which are constants. And in order to find out this, we need to consider a three set of characteristic data, that is P naught at any time T naught, and P1 at any time T1, and P2 at any time T2, where T2 is equal to 2 times of T1. That means at equal intervals of time we should consider these three characteristic data, that too in a useful range of census population record. So after considering this, you can find out the PS, M and N using this formula. and you can substitute here at any time. You can calculate the population at any time t. You can calculate the population. So this is how we will estimate the population using logistic curve equation. So let us solve a problem. Let us estimate the population of the future decades by considering some of any three set of population records. Let us consider this example. In two periods of each of 20 years, a city has grown from 30,000 to 1,70,000. That means earlier it was 30,000 and after 20 years it was 1,70,000, and in the very next 20 years, after 20 years it was grown up to 3 lakh. So we need to determine the saturation population. We need to estimate the equation of the, we need to get the equation of the logistic curve. Then we need to estimate the population after the next 20 years. That means the very next 20 years after the population reached 3 lakh, we need to find out what is the population after the very next 20 years. So from the given data, you can, if you observe the problem, first we need to consider three set of characteristic data. At t0, t0 is equal to 0, say for instance, p0 is 30,000. At t1 is equal to 20 years, p1 is 1,70,000, and at t2, the very next 20 years means after 40 years, as it is at equal period at each 20 years, as it is a equal intervals, t2 will be at 40 years, then p2 is. So if you plot this in graph, so this might be the graph. At t0 it is p0, and the very next 20 years it is p1, and very next 20 years is p2. So in this useful range, the data are given. By considering these three set of characteristic data, we can find out the saturation population using this formula. So by substituting the P0, P1, P2 in this, we will get the population, saturation population as 3,26,000. That means that city can extend up to this. This is P's. The city has the saturation population 3,26,200. In order to arrive the equation of the logistic curve, first we need to find out the constant, that is m, n. We already find out the PS as 3,26,000. So to find out m, we need to substitute PS, P0 and P0 here, so that we will get this 9.87 as m, and n, after substituting the things, you will get negative 0.119. So after substitute, and then you need to substitute m, n and PS into this equation, into the logistic curve equation. So this will be the final equation you will get. This is represented as a equation of logistic curve. At last, we need to estimate the population after the next 20 years. That means it is asking the population after next 20 years, means after 40 years it will be 60 years. So after at 60 years, what is the population? He is asking. That means at 60 years, what is the population? So in order to find that, so we need to take this equation itself. Then we need to substitute the 60 years in here. So after substituting, we will get 3,23,000 as the estimate. So this is the population at 60 years. So this is how we will estimate and find out the saturation population using logistic curve method. This is about the different population forecasting methods. By estimating the population by using any method based on the designer consideration, we will estimate the population, then we will estimate the water requirement at any design period. In turn, we will use that in designing the water supply systems. So in the very next video, we will be discussing about the water treatment flow, and in depth we will discuss about the different